today we're going to be covering adding and subtracting rational expressions. Now, before we can get into the addition and subtraction of rational expressions, I want to connect to what we have did before, which is just adding and subtracting with regular fractions, meaning fractions with numbers. So let's take a look at what we have here. We have 3/4 plus 2/5. In order to add or subtract fraction, we need to have same denominator. So let's find our common denominator. And we're going to label this as LCD, lowest common denominator. Now, the common denominator between 4 and 5 will be 20. So if I were to do 4 times 5, it will be 20. Now, in the past, when we were adding, subtracting fraction, you would just multiply and it would be 20. But here, what I want to do is I want to keep it in this form. Just two factors next to each other, 4 and 5. So what we're going to do here is that in the first fraction, I'm going to multiply, in the first fraction, let's compare the denominator with the LCD. It has a 4, but it's missing the 5. So what I'm going to do is I'm going to multiply the numerator and denominator by 5. Then I'm going to compare the second fraction. If I look at the denominator, compare it with the LCD, it has a 5, but it's missing a 4. So I'm going to multiply the numerator and denominator by 4. So that way, when you multiply, you're going to have the same denominator. So when I multiply, I'm going to multiply the numerator. So 5 times 3 is 15. And on the bottom, it will be 5 times 4. Plus, for the second fraction, again, I'm going to multiply the numerator. So 2 times 4, 8. But in the denominator, it's going to be 5 times 4. Now, if you look closely, you notice that the factors are in different places or in different order, which is okay. Since they're multiplying, order does not matter. So I repeat, since you're multiplying, since these two factors are multiplying, order does not matter. So right over here, for my LCD, we could have wrote 5 times 4, it still be the same thing, because 5 times 4 will also give you 20. Now, again, this format will be identical when we're adding and subtracting rational expressions. Now, once we have common denominator, both fractions have a 5 and a 4 where they're multiplying, we can combine the top. So it'd be 15 plus 8 over 5 times 4. Here, you can clearly see that we're just going to add 15 and 8 at the top, which will be 23 over 5 times 4. Or you could rewrite as 23 over 4 times 5. Now, I just want to remind you that sometimes you might just have a single number in the numerator, but when it comes to rational expression, you might have more than that, meaning numbers with variables or numbers with variables together, which we will go over step by step. But as we are progressing with adding and subtracting rational expressions, I will be reminding you about how to set up your denominator, because there are times where a certain order need to be written for our denominators. But here, as you can see, I didn't multiply the 4 and 5 to get 20. I just basically have it next to each other so that, again, it's in a different form, a form that now you need to get used to, because this is the form that you're going to be familiar with for rational expressions, so that when you're adding and subtracting, you get common denominator. Again, as I stated in the previous section, a factor can be a single number or a single variable or a number with variable. So again, the three types of factors can be a number, a variable, or a number with a variable. So those are three types. So here we just have two numbers that are our factors. So make sure to be familiar with all three types, because when we're adding or subtracting rational expressions, you can have a combination of those types altogether. Just make sure to be familiar with those types. Now in this example, we're going to be adding fractions where we have a monomial term for the denominator. So for both of these fractions, we have a monomial term, meaning one term in the first fraction and one term in the second fraction of the denominators. Now, the process is going to be similar to the last example that we covered, but the form is going to be a bit different, because here's why. When you're looking for your LCD, you will notice that in the first fraction, the denominator has 2m, so I'm going to write 2m. In the second fraction, we have 3n squared, so I'm going to write 3n squared. Now, in the last example, we didn't multiply the 4 and 5, but here we are going to multiply it. So basically, we're going to have 6 m n squared. So I multiplied the 2 and the 3 together because this is what our denominator is going to look like at the very end. But you can use this form that I wrote the first time to compare your denominator when we're adding and subtracting fraction. So again, when I multiply, you should have 6mn squared in your final answer. So let's take a look at our fractions and then compare our denominators with the LCD. And then I do highly recommend that you find the LCD first when it comes to adding and subtracting. So that way it's easy to compare visually, so that way you know what you need and what you need to multiply by so that you have common denominator. So let's take a look at the first fraction. If I were to compare the denominator with the LCD, it has the 2m, but it's missing the 3n squared. So I'm going to multiply the top and bottom by 3n squared. So I'm going to write right here for more space. So again, I'm multiplying the first fraction by 3n squared. Now, let's compare the second fraction and its denominator. We're going to compare it with the LCD. It has the 3n squared, but it's missing the 2m. So I'm going to multiply the second fraction by 2m. Now, when we're multiplying, I would like to put parentheses for the numerator. So that way, in the event when I'm multiplying, for example, this 2m to this expression, m minus 5n, here I can see that I need to distribute the 2m to the m here and the 5n. So again, that's why I like to put parentheses when I'm multiplying to the numerator. Now, I'm going to do this step by step. So I'm going to write it out. So the first part is going to be 3n squared times 5, then the plus sign, and then m minus 5n, also this is in parentheses, multiplying to the 2m, over, and as you can see, your denominator has the same factors, so I'm going to write 2m and 3n squared. Alright, so what I'm going to do now is that I'm going to multiply the first part. So 3n squared times 5 will be 15 n squared plus, now over here, I'm going to distribute the 2m, but for good practice, I'm going to keep the parentheses, and here's why, with the plus and minus. So 2m times m will be 2m to the second power, and then 2m times negative 5n will be negative 10mn over, now since we have the LCD, I can write 6mn squared. Now after that, I'm going to distribute my plus. So what I'm going to do is I'm going to have 15 n squared plus 2m squared, and then positive times negative 10mn will be negative 10mn over my LCD, which is 6mn squared. Alright, now the reason I did the distributed with the plus because I want to get good practice in the event when we're subtracting. So when we're subtracting, we work with minus. When you're distributing the minus, you might change some of these signs, so be very careful with that. Now, after I distribute the plus, I'm going to check if I can combine like terms. This is an n squared, this is an m squared, and this is mn, so I can't combine any like terms because there are none. And then I need to double check if I can simplify the fraction, which I cannot because all these numbers, 10, 2, 15, and 6, cannot be divided by the same number, so they will stay the same. In addition, I cannot simplify the variables because they don't have the same variable altogether. So this is just the n, this is just the m, this part here is the mn, while the denominator is also the same thing, mn. They all do not have the same variable, so I can't do anything simplifying the variable. So that means that I don't have to simplify this fraction, this rational expression, so therefore this is my final answer. And I'm just going to box it up. So that's all we have to do for adding this rational expression with two monomial terms.